Have you ever played a video game and been amazed by its massive, detailed world? Or watched a high-definition movie with incredible special effects and colors that pop off the screen? What if I told you that every single one of those amazing experiences, every photo, every song, every message you have ever sent, is made from just two numbers, 1 and 0? How is that even possible? Think about your phone right now. It holds your photos, your favorite songs, your conversations with friends, and apps that connect you to the entire world. It feels like it holds a universe of information. But at its core, a computer is a machine that runs on electricity. And for a machine to understand instructions, it needs a language that is incredibly simple and clear. What is the simplest way to communicate anything? It is a yes or a no, an on or an off. There is no maybe, no in between. Imagine a simple light switch. It can only be in one of two states. It is either on or it is off. This is the fundamental idea that all computers are built on. Inside every computer, there are not just one or two of these switches, but billions of them. They are microscopic electronic switches called transistors. Just like our light switch, each transistor can be either on or off. To make this easy for the computer to work with, we use numbers to represent these states. On becomes the number 1, and off becomes the number 0. This single piece of information, a 1 or a 0, is called a bit. It is the smallest, most basic unit of data in all of computing. But one bit on its own cannot do much. It is like trying to write a book with only one letter. You can say yes or no, but you cannot say anything complex. This is where the magic happens. What if we start using groups of these switches? Let's imagine we have 2 light switches instead of just one. With 2 switches, we can now create 4 different patterns. We can have both off, the first on and second off, the first off and second on, or both on. In binary code, that looks like 0, 0, 10, 01, and 11. By adding just one more switch, we doubled the number of combinations we could make. If we add a third switch, we double it again to 8 combinations. A fourth switch doubles it to 16. Every bit you add doubles the possibilities. Computers typically group 8 of these bits together. This group of 8 bits is called a byte. Think about that for a second. We have a row of 8 light switches. Each one can be either on or off. How many unique patterns can we make? The answer is 2 to the power of 8. Which gives us 256 different combinations. Suddenly, we have something we can really work with. With 256 unique patterns, we can start assigning a meaning to each one. We could decide that each pattern represents a letter of the alphabet, a number, or a punctuation mark. For example, a worldwide standard called ASCII decided that the binary pattern 01000001 would represent the capital letter A. The very next pattern, 01000010, was assigned to represent the capital letter B, and so on for the entire alphabet. This is exactly how your computer stores text. Every single character in an email or on a website is just a specific byte, a sequence of 8 ones and zeros. When you type the word code, your computer is actually storing 4 bytes, one unique 8-digit binary number for each of those 4 letters. That explains text. But what about the numbers themselves? How can ones and zeros represent a number like 58 or a million? The number system we use every day is called base 10 or decimal. We have 10 digits from 0 to 9 to work with. The computer's number system, as we have learned, is called base 2 or binary. It only has 2 digits, 0 and 1. In our decimal system, Each position in a number has a value that is a power of 10. We have the ones place, the tens place, the hundreds place, and so on. Binary works exactly the same way, but the place values are powers of 2. There is a ones place, a twos place, a fours place, an eights place, a sixteens place, and it keeps doubling. So when you see the binary number 1101, it is not 1,101. It means you have 18, 14, 02s, and 11. Add those together. 8 plus 4 plus 1 gives you the number 13. Using this method, computers can represent any number imaginable, from the score in your game to the complex calculations in a science experiment. Now for the most amazing leap. How does this system create a beautiful, complex photograph? Every digital image is made up of a grid of tiny dots called pixels. Your screen is just a giant grid of millions of these little lights. For a very simple black and white image, the computer just needs one bit for each pixel. It can assign a 0 for a black pixel and a 1 for a white pixel. For color, the concept is identical, it just uses more bits. Each pixel's color is described by how much red, green, and blue light it should emit. And the number representing the amount of red, it is stored in binary. The number for green? Binary. The number for blue? You guessed it, also binary. From here, everything else falls into place. A movie is just a series of thousands of still pictures, or frames, shown very quickly. And music is just a sound wave, sampled thousands of times per second, with the value of each sample stored as a binary number. So when you look at a vibrant photo or listen to a clear song, your computer is not really seeing a photo or hearing a song. It is processing an enormous list of ones and zeros, and it follows a set of rules to translate those numbers into the colors and sounds that we can understand and enjoy. Binary code is the universal translator between the physical world of electricity and the digital world of information. The reason it works so well is its simplicity. An electrical signal is either present or it is not. A switch is on or it is off. There is no ambiguity. This perfect clarity allows billions of these tiny decisions to be made every second, creating all the complexity we see on our screens. Every piece of modern technology, from your smartwatch to the satellites that guide our GPS, is built on this foundation of yes and no. The entire digital universe, with all of its art, knowledge, and connection, is constructed from this one brilliantly simple idea. So the next time you tap your screen or click a mouse, remember the invisible world of switches, flipping on and off to bring your digital world to life.